Hello, here in this video we're going to look at 9.3, solving quadratic equations by graphing. And we're going to learn a lot more about this word solving as it applies to quadratic equations over the course of this chapter. The first method we're going to look at is by graphing, because it's going to give us a really nice visual to tie back to what solving an equation means as far as it goes for quadratics. And the why for this is being able to interpret graphs and tables will enhance your science, business, and social studies skills. The Science ACT section loves having you interpret graphs and tables. This is going to help with that. Business, in terms of minimizing expenses, maximizing profits. Today's is going to bring in a new concept of a break-even point, right, to where you've gained or lost no money. Maybe you're in debt and then you paid it all off. That's essentially what the break-even point's going to be as it applies to solving quadratic equations. Social studies skills when you're just tracking graphs and tables. This is building our ability to do it. So let's jump on in. A quadratic equation, and we learned about this in the last videos, is ax squared. You need that x squared part to make it quadratic, and then plus bx plus c. And then there's something called roots of a quadratic equation. There's actually multiple words that all mean the same thing for solving a quadratic equation. Sometimes they'll call them roots. Sometimes they'll call it a solution. Sometimes they'll call it a zero. All those words mean the same thing. There's no particular reason why there's multiple names, there just are, so we'll need to be comfortable with them. So here it says the zeros, so that you're like, well, what's that mean, Mr. Cottle? Zeros is just another word for solutions. The solutions of a quadratic function are the x-intercepts. That's going to be the key. And if you remember, x-intercepts are coordinate points that are always some number, comma, 0. Therefore, finding x-intercepts is one way of solving the related quadratic equation. Alright? So, when we're asked to solve by graphing, graphing's in the title, so we'll need to graph it. Here's what they did. They went in using our formula from yesterday, negative b over 2a. They found the vertex, and they put the vertex into their table. Now, they didn't put their vertex into the middle of the table, which is what I recommend when we're making our own tables. But they found the vertex first and then completed a table to create a graph. And we're going to do this by hand lots of times. And what we're looking for to find solutions are the x-intercepts. So this x-intercept is negative 3, comma 0. This one is 2, comma 0. And you can see that the zeros, which once again just means solutions of the function, are 2 and negative 3, which is that same 2 and negative 3 right there. So it's very easy to see on a graph where the solutions are. It's because it's where it crosses the x-axis. It's the x-intercepts. Now, when we're doing it from a table perspective, because I mentioned tables, we're going to use the fact that x-intercepts are always where y is equal to 0. So the way that you find solutions in a table is you look in the y column, or y row in this case, and you look for where the y is 0. Wherever the y is 0, it tells you a solution. Now, what they did a bad job on is having their table show other values, because it's missing the other x-intercept. When we create tables, we're going to create tables that show all the x-intercepts, so both of them if there's 2. But that's how you do it from a table. You find where 0 is, and whatever the x-coordinate is, that's a solution. So this point right here of 2, comma 0 is that point right there. So that's the key. The x-intercept is wherever y is equal to 0. And I had mentioned that this section is almost nothing new compared to 9.1. And we'll see that all we're going to be doing is creating graphs, and then we'll just look into our table and look for anywhere there's a y-coordinate of 0. So let's go ahead and use these related graphs to determine their solutions. Now remember the way to graph. Step 1, so let's make a little box over here. To graph, step 1 is use negative b over 2a to find x-coordinate of the vertex. And then step 2, you start plugging in x to find y. And if you want, you can also utilize the fact that the y-intercept is always 0, c. Sometimes that can be helpful when you're calculating points as well. Alright, so let's take a look at this one. I've got a b value of negative 10. I've got an a value of an invisible 1. So let's do our formula of negative b over 2a, because that's going to tell us the x-coordinate of our vertex. So we'll go through here and we'll plug in negative 10 for b, we'll plug in 1 for a, and we'll get 10 over 2. The x-coordinate for our vertex is a 5. So I'm going to now draw up a table. And right in the middle of my table, I'm going to put that x-coordinate for my vertex. Now, anytime we want to find a y-coordinate, we need to go back to the original equation and plug in the x. And in this case, it was a 5. So we'll get 25 minus 50 plus 21. And you can put these together in any order you want. I'll go ahead and do 25 and 21 to get 46. 46 minus 50 gives us a negative 4. So there's my vertex. I'm going to come plot it. There is 5, comma, negative 4. And what that tells us is that we're going to have a quadratic that's symmetrical through that. There's our line of symmetry. What you should also recognize is since that a is positive, we are going to get a quadratic that opens up. So what we'll now do is we'll start to create our table by plugging in the x values that are nearby. And what you have to remember is that we're not going to be plugging in all of these, because since we put the vertex in the middle, these two are going to be the same. These two are going to be the same. These two are going to be the same. And the only points that we're looking for are when we can get a 0 in any of these y slots. If we get a 0 in any of those y slots, we have found the x-intercept, which is what we're looking for. So I'll go ahead and I'll plug in this 4 first. I'm going to plug in that 4 first, which is also going to get me the answer of if I plugged in a 6. They'll both get me the same thing. So I'm going to go to my original equation, and I'll be plugging in a 4. So we'll get 16 minus 40 plus 21. So this will give us a 37 minus 40. We'll get a negative 3 and a negative 3. So I'll need to keep going because I haven't found a 0 in the y spot yet. So let's try 3 and 7. I'm going to pick 3 because it is a smaller number. So here's the 3. Got 9 minus 30 plus 21. We just found zeros. And when we go to make this picture now, you know, the next spots we found were right there. And then we found a 3, 0 and a 7, 0. So here's our graph. We had 2 solutions. Those 2 solutions are the x-intercepts. So our solutions are that x is equal to 3 and that x is equal to 7. We found those in the table by finding a y-coordinate of 0. So there's the 3. Here's the 7. And that's all this section is it's making a graph, just like we did in 9.1, but we're looking specifically for the points where we cross over the x-axis. All right? So let's do some more here and keep finding some more zeros, because we just need to get graphing practice anyways. All right, so for this next one, once again, we're going to start off with negative b over 2a. My b is 4. My a is an invisible 1. So we've got here 4. Let me open up some parentheses here. And our a was 1. So the x-coordinate of our vertex is negative 4 divided by 2. So we get an x-coordinate of negative 2. I'm going to draw up my table. In my table, negative 2 goes right in the middle. To find the y-coordinate, we're going to plug in that negative 2 into our equation. Now notice that I'm leaving myself parentheses so that I have room to plug in my x-coordinate. It really helps keep track of negatives. Negative 2 squared is 4, minus 8, plus 6. This is a 10 minus 8, to get that our y-coordinate of our vertex is a 2. So I can go ahead and graph that. Negative 2, 2. It's going to land right there. Now, something you may have realized, especially if you've really been paying attention on this, is that this has a positive a value with it, which means that this quadratic is going to open up. So if we're looking for solutions, and we know that this quadratic to some extent is going to be opening up, right? We're not going to have any x-intercepts. We're never going to cross this. And if we wanted to quickly, make a better picture than this, I can leave my vertex there. We could utilize the fact that the y-intercept in this case is a 6. We could put that 6 there, and then simply reflect it across here. Because since this is the vertex, it's going to be symmetrical down through the middle. I don't need to make a table on this, because the goal on these was to solve them. This one will not have any solutions. What we're going to write is no real solutions. And you might be wondering, Mr. Cottle, what's that word real doing there? Why do we need that? What's that mean? When you get to Algebra 2, you'll understand why you need that word real. There are actually things called imaginary solutions. So, that may be surprising to you because it sounds very strange. But when we're talking about quadratics and there's no solution, we'll say there's no real solution. And that happens when we do not have any x-intercepts. We have no x-intercepts here. No matter how many values I put in my table, even if I counted down all the way to negative 10, or all the way up to whatever, we would never get any zeros in the y column because this graph will never hit the x-axis. So this is called no real solutions. Let's check out this one and see what it's up to. We'll start off with negative b over 2a. b is 4. a is 4. When we substitute this one in, we'll get the x-coordinate for our vertex is negative 4 over 8, so it gives us one of 1/2. Alright, now, that's fine. You might start freaking out because you don't like fractions, but we're going to follow the same old procedures, and it would be a negative 1/2. So we have a negative 1/2. I'm going to put it right in the middle of my table because it's my vertex. To find the y-coordinate for our vertex, we're going to need to plug in the negative 1/2. But it's not going to be as bad as you think. Negative 1/2 squared is negative 1/2 times a negative 1/2. We know that we multiply fractions straight across. So when we do that, the 4 is still there. Negative times negative is positive. 1/2 times 1/2 is 1/4. Then here for this next one, it's 4 times a negative 1/2, which will turn us negative and make it a 2. Because 4 times negative 1/2 is really just 4 divided by negative 2. 4 times 1/4 is 1. So we get a 1 plus 1 here is 2. 2 minus 2 gives us a y-coordinate of 0. Okay, now, we've already found one of our solutions. It's at negative 1/2, comma, 0. And if you think really hard, you might be able to understand that this one is also all the way finished now, because yes, we could make the graph, but we're just trying to find its solution. We found the solution. The solution of this is x is equal to negative 1/2. But you might be wondering, why don't I need to look for the others? Sometimes there was 2, right? This one had 2. This one had none. But this one's actually just going to have 1. Because this quadratic opens up. You know, we could go ahead and plot its y-intercept of 1 and make its reflection. So this quadratic is doing this. It's not going to have a second x-intercept. The only x-intercept it's going to have is this one. Alright, and so what these 3 pictures represent are the 3 different options of the types of solutions you can get. You can have some graphs that have 2 solutions. Another example of a 2-solution graph, something like this, where there's 2 x-intercepts. You can have no real solutions. Right, and that would be some scenarios like this, to where the quadratic will never hit the x-axis. And then for the final one, there's an option of 1 solution, right, and that's going to happen when your vertex is the solution. If your vertex is the x-intercept, that's going to give you 1 solution. You know, so it could look something like this as well. Vertex right there, opening down. That's another example of 1 solution. So all this section is it's the same skills we needed to graph out of 9.1. Finding your vertex first, placing that in the middle of your table, you know, using symmetry to generate other points, and then determining where do we have x-intercepts. X-intercepts on the graph you can see very easily. It's where you cross the x-axis. X-intercepts in a table are where the y-coordinate is 0. Alright, so let's just go ahead and do one more here together, just so that we're all kind of on the same page. Now, I'm going to go ahead and warn you that this one's not going to have x-intercepts that we can find with our particular method. It's going to get us some good graphing practice, which is important, but then we'll talk about, you know, why solving by graphing isn't going to be the best choice moving forward, and it'll allow us to get comfortable with the concept of having other methods of solving that we'll learn later. Let's do this one here in the middle. I want to graph it so that I can find where do I cross the x-axis. We'll do that by using negative b over 2a. b is 6, a is 1. So the x-coordinate of our vertex is negative 6 over 2. so it's a negative 3. So within my table, negative 3 will go right in the middle, and to find the y of our vertex, we're going to plug in the negative 3 back into the equation. Negative 3 squared is 9, minus 18, plus 6. This is a 15 minus 18 to get negative 3. So we now know that our vertex is negative 3, negative 3. We know we open up because of this positive a value. So I know I'm going to hit the x-axis highlighted in red twice, but we don't know where yet. And we'll need to find it by trying some different values that are nearby. And remember, as long as you put your vertex in the middle, this will have symmetry and this will have symmetry. So I'm going to plug in either negative 2 or negative 4. They're going to have the same answers. I'm going to go ahead and pick the negative 2 one though, because it's a smaller number. And when we place the negative 2, we'll get 4 minus 12 plus 6. So here's a 10 minus 12 to get us negative 2. So we can graph those symmetrical points on there. And then now we could plug in either negative 5 or negative 1. I'm going to plug in negative 1 because it's smaller. Negative 1 squared is 1, minus a 6, plus a 6, this is a minus 1 here. These cancel out, leaving us with a y value of 1. So when I come up to graph this next one, you'll see that, yes, we crossed the x-axis, but it wasn't at a whole number. Right, and we skipped over 0 because somewhere in between negative 2 and 1 is 0. Somewhere between this negative 2 and 1 is 0. So we can't quite tell where the x-intercepts are exactly, but we know that they're in between negative 2 and negative 1, and we know they're in between negative 5 and negative 4. We're going to learn later on in this chapter how to solve these with other methods so that I could find the exact decimal. I could guess. You know, that one looks like it's about x is equal to negative, I don't know, 1.3, somewhere around there, approximately. This one over here, x is approximately, you know, negative 1, 2, 3, 4, negative 4.6, somewhere around there. But we couldn't find them exactly. So before we conclude today, remember the key. You want your vertex right in the middle, and then solutions are x-intercepts, which means you're looking for that y-coordinate of 0. So say you found some y-coordinates of 0, that x-coordinate is your solution.